So here we have some evaluating of expressions and something called the zero exponent property. So let's talk about that zero exponent property. There is this wonderful property in math that tells us that anytime you raise a base to the power of 0, like this example right here, 4 raised to the 0 power, if 0 is your exponent, this will always equal 1. So the thing to remember about this is, obviously, anything raised to the 0 power equals 1, but also that it doesn't matter what your base is at all. I could take a base of 42, raise it to the 0 power, because of that 0 exponent, it's going to equal 1. I could take a negative base. I could do negative 4 raised to the 0 power. Because it's being raised to the 0 power, it equals 1. I could take a really big number, 2,475 raised to the 0 power. Again, whatever these bases are, it doesn't matter. If it's raised to the 0 power, it equals 1. So the nice thing about this property is it's really easy to use. The hard thing is we have to remember that anything raised to the 0 power equals 1. So it's easy to do, but it's also easy to forget. So just be careful with that. Alright, now we're looking at 3 to the 3rd power. This is just working on making sure we know how to evaluate expressions with exponents. 3 to the 3rd power, you want to look at what your base is, and we're going to rewrite this without the exponents. Our base is 3, and how many 3's are we going to multiply? That's what our exponent tells us. So we're going to multiply 3 of these. 3 times 3 times 3, and then we're going to figure out what that equals, because we are asked to evaluate the expression. So just go in order. First do the 3 times 3. 3 times 3 is 9. And now multiply your 9 times 3. 9 times 3 is 27. So you get a 27 on that. Be careful about the most common mistake I see. And I feel like sometimes students don't even realize they're doing it. Our brain will just put numbers together automatically before we have a chance to even think about what the problem is all about. So I will see students take 3 to the 3rd power and actually multiply 3 times 3 and get 9. So please don't do that, because that's not going to give you the right answer. You want to actually multiply out that base however many times the exponent tells you to multiply. Alright, and then this last example brings in a variable. We have 4x squared. We have to evaluate this when x equals negative 2. So in this example, we know what x equals, so we are just going to go ahead and plug in that negative 2 for the x. So you have 4. When I plug in numbers for variables, I put it in parentheses, so here's my negative 2. Because the 4 is right next to the negative 2, that does indicate multiplication, so I'm good there. And then I'm going to raise it to the 2nd power. So from here, you have two options. You can do 4 times negative 2 and then raise that to the 2nd power, or you can do negative 2 squared and then multiply it by negative 4. So how do we know what we should do first? This all comes down to your order of operations. Remember how much we love PEMDAS, and we actually do love it because it gives us an easy way to remember how to go about evaluating an expression. So start with P, parentheses. Inside my parentheses I have a negative 2. There's not an operation in there, so I can't really do anything. Then I move on to E, exponents, and guess what? We do have an exponent. This squared is only the exponent with this base. So we are going to go ahead and evaluate negative 2 to the 2nd power. I haven't touched the 4 out front yet because I haven't gotten to that part of my order of operations. Negative 2 squared is a negative 2 times a negative 2. Negative times negative is positive, so this is going to give me a positive 4. And now I'm going to bring down the rest of the problem. I have a multiplied by 4 out front, and now I get to the multiplication and division part of order of operations. 4 times 4 is equal to 16. So that is the final answer there. Again, this mistake I would see students make is doing the multiplication before the exponents, but that doesn't follow your order of operations. So just remember PEMDAS and you'll be great.